Oh, awesome. You can see my screen now. Perfect. So this is the example I was talking about. Wonderful. Let's find the linearization of f of x equals the cube root of 1 plus 3x at a equals 0. So from the last part that we just chatted about, the linearization of a function is given by L of x equals f of a plus f prime of a times x minus a. So let's figure out a few things. The easiest one, I think, is f of a. So in this case, a equals 0. So f of a equals f of 0 equals the cube root of 1 plus 3 times 0. So we just end up with 1. All right, so now let's find the derivative of f. So f prime of x, and I can rewrite f of x really quickly just to make my derivative easier. 1 plus 3x to the 1/3 power. So this is 1/3 times 1 plus 3x, and then here I have 1/3 minus 1 power. And then I have to use the chain rule because I have a function in a function. So I'm going to multiply by the derivative of 1 plus 3x, and that derivative is going to be 0 plus 3, so just 3. So then I have this 3 in the numerator, this 3 in the denominator. Those divide to 1. And I'm left with f prime of x is equal to, and what is this exponent? I have 1/3 minus 3 over 3, so that should be a negative 2 over 3 power. So 1 plus 3x to the negative 2/3 power. So now we can evaluate at 0. So f prime of a equals f prime of 0. And that gives me the 1 plus 3 times 0 to the negative 2/3 power. So again, we're just going to end up with 1. So our linear approximation is L of x equals 1 plus 1 times x minus 0, or just equals 1 plus x. So for values really close to 0, we can approximate this function without a calculator using x plus 1. So for part 2, that's what they asked us to do. Use the linear approximation for part 1 to estimate this value, the cube root of 1 plus 0.03. So first we have to figure something out. 1.03 has to somehow equal 1 plus 3x. So 0.03 has to equal 3x. And then using a calculator, we can figure out what that is. Even not a calculator, what would x be in this case? It would be 1 over 100. And why is that? Because 1 plus 3 times 1 over 100 is 1 plus 3 over 100 is 1 plus, and I'm going to move my decimal place over 1, 2 places, 0.03 or 0.03. And that's what we're trying to estimate. So that tells me in this case, x is going to equal, like we have here, 1 over 100, and I'm going to use that in my approximation. So all I'm doing is taking this value of x we found and plugging it into this linear approximation. So that tells me L of x is equal to 1. Oh, I should actually write in what x is. 1 over 100 is equal to 1 plus 1 over 100. So 1.01.